This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic is Definitions and Terminology of Electrochemical Processes, Part 2. Okay. So, in the previous presentation, we have discussed same electrochemical processes, okay, Part 1. Now, at the end of this session, student will be able to understand the definitions and terminology of electrochemical processes. Okay, right. This is the course learning outcome of the topic. Right. Abrasive flow finishing, AFF, abrasive flow finishing. Principle, definition, process description. Okay, definition uses a flow of abrasive laden media to smooth or polish surfaces. Okay, uses a flow of abrasive laden media to smooth or polish surfaces. Next, process description. Abrasive media is flowed over the workpiece, performing finishing operations through abrasive action. Okay, so abrasive flow finishing. Okay, principle, under that we have definition and process description. Okay, just focus on the definition now. Okay, uses a flow of abrasive laden media to smooth or polish surfaces. Okay, what will happen here? Uses a flow of abrasive laden media to smooth or polish surfaces. Right. Process description. Abrasive media is flowed over the workpiece, performing finishing operations through abrasive action. Okay, so what is flowing here? Abrasive media. Okay, abrasive media is flowing over the workpiece surface, okay, to perform finishing operations through abrasive action. Okay, right. Okay, at a glance, let us look at the entire presentation. Okay, right. Now, process variables. Okay, flow rate, abrasive media. Okay, see here in the machining process, each and every parameter process is very much important. We have to regulate, okay, each and every parameter. Okay, so then only we will get the expected quality and the accuracy. Okay, so here flow rate and abrasive media are the process variables here. Right. Flow rate, speed at which abrasive media flows over the workpiece. Okay, flow rate nothing but speed at which abrasive media flows over the workpiece. Okay, so we cannot expect the material removal rate by the unknown or unpredicted abrasive media flow. Okay, so we have to control the flow rate, okay, as per our the requirement. Okay, flow rate is speed at which abrasive media flows over the workpiece. Right. Next, second one, abrasive media. Type and size of abrasive particles used. Okay, so abrasive media under this type and size of abrasive particles used. Okay, what type of abrasive particles that we are using. Okay, there are so many abrasive particles like Al2O3, okay, SiO2, okay, SiC, okay, like that. There are so many abrasive particles are there. Okay, so we have to choose appropriate abrasive particles as per our requirement. Applications: suitable for polishing and deburring complex geometries and internal passages. Okay, right. Polishing means to get the mirror finish surface. Okay, deburring means while we are machining, some debris of that machining may retain to the workpiece, or sometimes while we are removing, some particles may tend to come out, but those particles do not come out completely. That is nothing but deburring. Okay, so here excuse me. So here it is suitable for polishing and deburring complex geometries and internal passages. Okay, right. Limitations: requires careful control of process parameters for optimal results. Okay, so optimization is also important one, and at the same time we have to get the optimal results. So for that, some machining processes may not be suitable. That is some limitation of the manufacturing scenario. Okay, so here requires careful control of process parameters for optimal results. Okay, key terminologies: abrasive media, flow rate, particles suspended in a liquid or gel used for finishing. Okay, so what here? Abrasive media, particles suspended in a liquid or gel used for finishing. That is about abrasive media. Okay, flow rate, speed at which the media flows over the workpiece surface. Okay, so what does it mean? Flow rate, speed at which the media flows over the workpiece surface. Okay, and just let us discuss abrasive media once. Okay, particles suspended in a liquid or gel used for finishing. Okay, so these abrasive particles will be suspending in liquid or gel, okay, used for finishing. Okay, right. Electro stream drilling. Electro stream drilling principle. So here definition and process description are the two items to discuss. Uses an electric field to direct an abrasive slurry for drilling holes in materials. Okay, so in order to make holes through drilling, what we have to do? An electric field set up with an abrasive slurry. Okay, so here uses an electric field to direct an abrasive slurry for drilling holes in materials. Okay, so here the system is electrical, electro stream drilling. Okay, so this electric field directs an abrasive slurry for drilling holes in material. Okay, right. Process description. Abrasive particles are directed through a high voltage electric field to drill or erode material. Okay. Process description. Abrasive particles are directed through a high voltage electric field to drill or erode material. Okay, right. Applications and limitations. Used for drilling precise holes in hard or brittle materials. Okay, so what are the applications and limitations? Let us discuss here. Applications and limitations. Okay, applications. Used for drilling precise holes in hard or brittle materials. Okay, now let us assume a, what is that called, a shipbuilding structure. Let us say we need some small holes. Okay, small holes, and assume that the material is very hard and brittle, where we have to use the technique. Okay, so used for drilling precise holes in hard and brittle materials. Okay, so usually in surgical equipment and in defense equipment, we need to make precise holes, and those materials are usually hard and brittle. Okay, so usually the weapons do not have the property of ductility, and the materials should not be soft. Okay, so we have to use hard materials. Again, from those hard materials, we have to remove the material very precisely, maybe in tens of some grooves or slots, or sometimes drilling holes. Okay, sometimes in the engines, aeronautical applications or automobile applications, sometimes of spray of the fluid or fuel need to be operated. Okay, sometimes in surgical products, we need to have precise drill holes. So where we have to use this application. Okay, this technique. Okay, in those applications we have to use this technique. There the materials are very hard and brittle. Okay, next, limitations. Limited to specific materials and require precise control of electrical parameters. Okay, that's what I'm saying. Here we need to control electrical pulses, and we need to regulate different parameters. Okay, fluid flow rate. Okay, so all these things are very complex. Okay, so if we have the Pakka mechanism to control all these parameters, heat and flow, and electrical pulses and all these things, then only we will get the accuracy. Okay, otherwise we cannot expect. So particularly in defense and aerospace and shipbuilding and medical area, we must have appropriate machining characteristics. Okay, like slots, grooves, holes. Okay, so these features will play predominant role in the functioning of that equipment. Okay, so the expected features will get only because of the controlling of the process parameters. Okay, so here one of the limitation is that limited to specific materials and require precise control of electrical parameters. Okay, right. Next, key terminologies. Electric field. Electric force used to guide abrasive particles in the drilling process. Okay, electric force used to guide abrasive particles in the drilling process. Okay, so under this key terminologies, one is electric field, the other one is abrasive slurry. So wherever we get the abrasive slurry, almost the same in the almost all the processes. Okay, we do not worry about that abrasive slurry in the different machine systems. Okay, right. Electric field. Electric force used to guide abrasive particles in the drilling process. Okay, so electrical field should be strong enough to control all these things. Okay, why? Because it guides the abrasive particles. Okay, so abrasive particles are controlled by the electric field. Okay, so electric field is the responsible for the controlling the abrasive particles, controlling and guiding the abrasive particles in the drilling process. Okay, right. Abrasive slurry. Mixture of abrasive particles and liquid used for material removal. Okay, abrasive slurry. Mixture of abrasive particles and liquid used for material removal. Okay, right. Electrochemical processes. Fundamentals of electrochemical machining, ECM. Definition and process description. Uses electrochemical reactions to remove material from a workpiece. Okay, uses electrochemical reactions to remove material from a workpiece. Next, process description. Electrolytic dissolution occurs when a workpiece is placed in an electrolyte and an electric current is passed between the workpiece and a tool electrode. Okay, so one side tool, the other side is workpiece. Okay, right. Definition. Uses electrochemical reactions to remove material from a workpiece. Not only electrical, not only chemical, electrochemical reactions. Okay, so here chemistry is one and electrical technology is other one. Here for the material removal, contributing both electrical and chemical reaction. Okay, right. Process description. Electrolytic dissolution occurs when a workpiece is placed in an electrolyte and an electric current is passed between the workpiece and a tool electrode. Okay, right. Electrochemical grinding combines grinding with electrochemical removal for efficient material removal and improved surface finish. And in process description, uses a conductive grinding wheel and an electrolyte to achieve both mechanical and electrochemical material removal. Okay, so in electrochemical grinding, what is happening? Combines grinding with electrochemical removal for efficient material removal and improved surface finish. Okay, and in process description, uses a conductive grinding wheel and an electrolyte to achieve both mechanical and electrochemical material removal. Okay, so here both mechanical and electrochemical material removal contribution is existing. Next, electrochemical honing and deburring. Processes that use electrochemical reactions for finishing and deburring. Okay, so in electrochemical honing and deburring, same processes that use electrochemical reactions for finishing and deburring. Okay, as like the previous techniques. Process description. Electrochemical reactions are used to smooth and deburr surfaces. Okay, so here electrochemical, both electrical and chemical reactions are performing the finishing and deburring operations. Next, metal removal rate in ECM. Okay, that is calculation part based on current density, electrolyte composition and material properties. Okay, so metal removal rate in ECM, electrochemical machining, okay, based on current density, electrolyte composition and material properties. Okay, right. Tool design. Design considerations. Shape and material of the tool electrode affect the efficiency and accuracy of ECM. Okay, so tool design, design considerations are very important. Shape and material of both tool electrode affect the efficiency and accuracy of the ECM. Applications and limitations. Applications. Suitable for complex geometries and hard materials often used in aerospace and automotive industries. Right. Limitations. Require careful control of process parameters and is limited to electrically conductive materials. Okay, so this technique is limited to electrically conductive materials. Okay, right. Key terminologies: electrolyte, electrolytic dissolution. Okay, solution used to conduct electrical current and facilitate material removal. Okay, what electrolyte does? Okay, it facilitate the material removal. Okay, what is electrolyte? It is a solution used to conduct electrical current and facilitate material removal. Next, electrolytic dissolution. Removal of material through electrochemical reactions. Okay, so already we have discussed that one. Okay, thank you. With this, I'm concluding.
Like, share and subscribe. Hit the bell icon for more updates.